Hello Paul and all the community of developers. This is a follow-up of a series about Raspberry Pi playing with GPIO, and I'll explore the possibilities of pulse width modulation, playing with scope too. So to make our tests, I set up a simple circuit on an LED here. It's 220 ohm resistor as usual, and I connect this to pin 37 and GPIO 37 and the ground 39, just like you did before. I think this is 220 ohms. Okay, so this is to illustrate pulse width modulation, as there is no possibility to have a continuous voltage from GPIOs. We have, for instance, 3.3 volt. The idea is to play with here a pulse width on a given frequency. So in a cycle, if the pulse width here is 50%, we'll talk about the duty cycle of 50%. Okay, this is one cycle here, one period. So to illustrate this, what we mean here is that if voltage is high, half of the time is the same as if we had in analog world half the voltage, which would be here 1.6 volt analog. That's the idea. Okay, so I go back to my screen with my board here and the scope. I'll turn it on here. It's just a little one, it's not a big one as a Paul has. Okay, there must be, yes, the things here, okay. Okay, that's it. Okay, and this is my command line here. So I will first start Python 3 here. Okay. We'll start with importing GPIO. Let's see. RPI.GPIO as G Okay, we'll set the mode here on the board because it's the most obvious and the most direct way of talking to the pins. And we'll say here that pin 37 will be G.out so that we can send a signal through this pin. Okay, then yes, if we look at the scope, it's still at 0. We can then send an output on 37 here and set it to high level. Okay, and you see on the scope that value is now high, which is 3.2 volts. Yes, which is about what is it expected. Okay, then we can set it on 0. And we see that the level comes back to 0. Okay, I think I'm on 10 millisecond scale here, so maybe if I just send it back to 1, we'll see the change. Yes, I will remove the screen display. Yeah. So maybe we can see the change easier here. I will go to 0 and back to 1. Yes, we saw the change passing by. Okay, so the scope is working. Now we will set our pulse width modulator. Okay, we will instantiate, we will get an instance here, PWM, as what would it be? G.PWM. Okay, and we set it on pin 37, and we have to define a frequency. And the frequency will be the number of cycles per second, which is expressed in hertz. 100 hertz will be nice here. Okay, then next we have to start the modulation. And when starting the modulation, we just give the duty cycle. And as a beginning, we will start with a 50%. Here, and boom, we have it on the scope. Okay, graduations, grid is not very easily readable here. Yes, you can see you have a up and down cycle in 10 milliseconds. if we display values, okay. We see here that the voltage is considered as 1.58 volt. Yes. Okay, we have a average voltage here, which will be read as a analog equivalent voltage. Yeah. I'm not sure you can see the strength of the LED, so maybe we will change the duty cycle here. And we will set it at 20. Yes, boom. Okay. So it's not very obvious about the brightness here, but on the scope you see that the duty cycle has dropped. It's very thin now. I mean the on part of the period. Okay, if we go still lower here, then yeah, okay, 5. Okay, it's decreasing. 1. No, it's dimmed. Okay. Right, that's it. That's all I wanted to show with the scope. Same. Yeah. And this is maximum. Maximum goes to full, which is not very demonstrative here. 99. Yeah, it's more interesting here. You just see the thin line dropping. Okay, thank you for watching. I'll be back later for the assignment. Thank you. See you all. Bye.